This will be the axis of the roller. This will become like a solid cylinder and you are going to pull this one. What about the friction? How friction should act? Friction will act backward. Just now you have studied, and this is the center of mass. It will be like this. And what all you applied force, F/2 will act at this end, F5 will act at this arm. That we are showing the plane diagram that force F is acting here. Please do understand this is something very important at this stage for you. Okay, what is the resultant diagram? The resultant diagram, we just show it like this. A force F is acting, then the friction will act backward. Sir, how you can apply force at center of mass? The background is this one. Huh? This is the diagram. Things will be off like this. Getting this one? Okay, now let's take the next condition. So directly, I'll bring it to the this will be more troublesome for you, the diagram. 3D diagram also, try to assume you'll be in a better position. This is small r. This is capital R, and this is a ground. It is kept on rough surface. I'm going to apply force F like this. Then let I be the moment of inertia, let M be the mass of it. Then whatever the friction, all the things. So how to analyze such a things, that one. So it is practically what will happen, it will be of like this. I'm trying to draw the 3D diagram. I can wound a wire, I'll wound a string. Can I pull it? And it is kept on. Able to make it out. So now what will happen? It starts rolling, no? Charka, kite. So you can tie strings to the both the ends. So in fact, like I'll complete the diagram. Some of you are getting confusion. Here I'll pull with F/2 force. I'll tie another string. So what is the net force acting now? F only. If I pull this, what will happen? I think you can do this one. Huh? Take any object, tie one string here, and pull both the strings with the same force, F/2, F/2. The plane diagram is what this one. What is the moment of inertia? It's not a cylinder, am I right? I can call this a differential pulley or axial shaft, anything you can call it. And the surface is rough. Okay, now I'm asking what is the acceleration of center of mass and friction. So what is the method now? So the friction, I'm just assuming like this. Sir, how do you can say? I don't know. I just assuming that one. The acceleration of center of mass. Let it be. Let there be talk. What are the equations of motion? You can write it. F minus small f equal to mac. Then torque equation, F into small r clockwise. F into small r clockwise. Then F into capital R, this is also clockwise, equal to IC alpha C. For pure rolling, what is the condition? AC should be equal to R alpha C. This condition, acceleration of this point. From that, I'll write AC equal to R alpha C. Solving this, we'll get the required answer. I think you should not be in a big trouble, no? Sir, how to do this such problem? You can manage. Now, instead of pulling horizontally, can you pull this same differential pulley vertically up? This force, can you apply it here and start pulling it? Why to pull like this? This you are going to wound a string. Instead of pulling the string horizontally, you hold it vertical and pull it. If you are very much interested to learn physics, you want to become engineer, today I think what all sir gave examples, let me try. You just want to get a rank without knowledge, I think you are not going to do anything practically. It's left to you. Huh? because I can't force you to become engineer. You must have the desire to become a skilled engineer, not accountant. If you want to become accountant, okay, don't do anything. Just listen to my class. Next, the same thing. Can I pull it? I'll wound a rope string. I'll pull it here. I'll pull vertically up. I can pull this vertically. No, there's no any condition that it must be pulled like this only. Now, anything can you say about how the friction you are going to assume here? How to predict the direction of friction? Now the applied force is less than the weight of the pulley. Let m be the mass of this differential pulley. I applied a force which is less than the weight. Then how do this will rotate? No slipping occurs. That's a strict condition. First of all, any torque about center of mass by applied force is little bit torque. What about torque due to weight? Weight and normal contact will intersect axis of rotation. They cannot set up torque about point P or about C. But the applied force can set up torque about center of mass or about point P. Let me take about center of mass here. So how the torque, this is smaller, this F, clockwise, no? So because of clockwise torque setup, only torque is set up initially. The point of, and you try to rotate clockwise. There will be an clockwise. And because of this clockwise torque, this particular point P what pen will have acceleration towards left, R alpha C. And for no slipping, there must be acceleration of center of mass towards right. So the acceleration of center of mass. Who can provide that acceleration of center of mass? The friction. Finish sure. So then what is the equations you can write? F equal to MAC. Then the torque equations will be F into small r is equal to IC alpha C. Condition for no slipping or alpha C. You can pull horizontally, you can pull vertically. A rigid body, there's several ways of it, what you can pull it here. And now sometimes a rigid bodies can be connected to each other.